Hello children, this is your physics teacher Sharma and I welcome you all back to my class. In the previous classes we were discussing about physical and different chemical properties of metals, wherein we learned how metals react with acid, how metals react with oxygen present in the air. We have learned how metals react with water and how metals react with salt of another metal. And that is when we came across reactivity series. Today we are going to discuss about a topic which explains us how a metal reacts with a non-metal. To understand this, I need you people to remember, recollect, recapitulate what you have learned in your 9th standard. If you remember, when we were discussing about, when we were learning about atomic numbers, we also came across electronic configuration. Electronic configuration is nothing but the arrangement of electrons in different shells of the atom or different orbits of the atom. Suppose if I take a metal like magnesium, we all know very well that magnesium atomic number is 12. So, in an atom of magnesium with the nucleus at the center, first shell has 2 electrons, second shell can accommodate 8 electrons, this completes total 10 electrons where the atomic number is 12. So, the remaining 2 electrons will be accommodated in the third shell. Now, following octet and duplet rule, to attain stability, an atom should be having completely filled outermost shell, or the outermost shell should be having 8 electrons in it. Now, this third shell is the outermost shell and it does not have 8 electrons, it has only 2 electrons, which leaves magnesium with 2 choices. One of those being attracting another 6 electrons or losing these 2 electrons away. Obviously, it is more easy and it requires very little amount of energy to remove these 2 electrons. So, magnesium, which is an atom, it loses 2 electrons to give Mg2 plus ion. Okay, so magnesium atom loses 2 electrons to give magnesium ion. In the same way, sodium has an atomic number 11. With atomic number 11, we can write the electronic configuration of sodium as Na. It is 2 in the first shell, 8 in the second shell, so total 10, and 1 more electron in the third shell. So, sodium would lose this electron. Sodium would lose this electron to form Na plus ion, sodium ion. Okay, so I can write that as an equation. Na gives rise to an electron, or it gives away an electron to form Na plus ion. Okay, similarly, if we look into other elements like chlorine, whose atomic number is 17, has an electronic configuration 2, 8, 7. Now, chlorine is not having 8 electrons. At the same time, it is not having 1 or 2 electrons which it can lose. It has 7 electrons. Now, amongst the 2 choices it has of gaining 1 electron or losing 7 electrons, it is more convenient, or it requires very little amount of energy to gain 1 electron instead of losing 7 electrons. So, chlorine, an atom of chlorine it gains an electron to form chloride ion. Similarly, other elements also. Actually, we define metals and non-metals based on the number of electrons it is gaining or losing also. If an atom is having 1, 2 or 3 electrons in the outermost shell, we say it is a metal. On the other hand, if an element is having 5, 6 or 7 electrons in the outermost shell, then we say it is a non-metal. All metals will have the tendency to lose electron to become positively charged. On the other hand, all non-metals will have a high electronegativity. That means the ability to gain electrons to become negatively charged. Okay, so this is how ions are formed. So we have a metallic ion, we have a non-metallic ion. Now this metallic ion and non-metallic ion, they combine with each other to form a compound. Let us see how that happens. I will take the example of calcium. Calcium, which is having atomic number 20, is having an electronic configuration 2, 8, 8, 2. So it has 2 electrons in the outermost shell. As it is having 2 electrons in the outermost shell, it loses 2 electrons. So calcium loses 2 electrons to form Ca2 plus ion, calcium ion. Suppose I take another compound or another element which is a non-metal. I would take chlorine. Chlorine atomic number is 17. Now, chlorine has electronic configuration 2, 8, 7. This chlorine has 7 electrons in the outermost shell, so it will gain that electron. Now, try to understand. Chlorine is giving 2 electrons away. When that comes in contact with this non-metal chlorine, it gains those 2 electrons. That means 2 chlorines will gain 2 electrons to form 2 chloride ions. Now, we have Ca2 plus ion that is now in contact with Cl minus ions, 2 of those. What happens when these 2 react with each other? We get calcium chloride. How we got CaCl2? That we have learned in 9th standard. Let me explain once again. When we have calcium Ca2 plus ion and chlorine, it is a Cl minus ion. We use a method called crisscross method, wherein we write the element without any symbol. The valency or the oxidation number of one element is written as the subscript for the other element. The valency of calcium is 2, the oxidation number is 2 plus, so I write this as subscript for chlorine. Similarly, for chlorine it is 1, I write this for 1. For calcium I write it as 1. So it is CaCl2. So when calcium is combining with chlorine, we are getting calcium chloride. Similarly, if magnesium combines with sulfur. Sulfur, it also gains 2 electrons to become S2 minus ion, and magnesium, it loses 2 electrons to form Mg2 plus ion. Then what happens? Magnesium, it gives away 2 electrons to form Mg2 plus ion. Sulfur gains 2 electrons to give S2 minus ion. So this magnesium will combine with sulfide ion to form magnesium sulfide, which is MgS. Okay, so this is how a metal reacts with non-metal. This part of the lesson is not only important because it is giving us the information about how metals are reacting with non-metals. It is silently also passing an information that what we have learned in our previous classes, whether it is 8th or 9th or even 7th for that matter, that is very important to understand and remember. For today's class, this is it. Have a nice time until we meet again.